full
This
screen,
conference
Andy?
will now be recorded.
It's not come up yet, no.
Okay, let's try this. Right,
This conference
apologies,
will now be
technology,
recorded.
Technology get the better of us. Okay, well, good evening. And here on the Isle of Man, everything comes in threes. As you'll see from the logo in the bottom right-hand corner, the symbol for the Isle of Man, the Triskelion flag, is of the three legs of man. This is the third presentation I've done to the South Wales and West Wales section on the Permanent Way and the Isle of Man railways. First one was back in 2012, then 2017, and now this one. It's the first time I've done one live from the Isle of Man, so this is a step forward. Unfortunately, it means I can't talk to you in the way that it was usually very good to come over and chat to people as former friends and colleagues as well. So this evening we're going to go through things about the Isle of Man railways. In the Isle of Man, when I talk about the Isle of Man railways, I'm referring to the four railways that the government own and operate. That's the Isle of Man Steam Railway, the Manx Electric Railway, Snafel Mountain Railway, and the Douglas Bay Horse Trams. There are actually a number of other railways here on the island, including the Groudle Glen Railway and the Laxy Mines Railway. The Groudle Glen Railway markets itself as the little line that goes uphill to the sea. And I'll leave you that as a brain teaser to ponder through the evening. I'll give you the answer at the end to see if you can work out how that's possible, to have a line that goes uphill to the sea. So, if we talk about the Isle of Man, what do you think of? Well, for anyone who's hoping to tune in and have a presentation on track works associated with replacement of 1938 underground stock, that's the Isle of Wight. That's the one down in Southampton, near Southampton. The Isle of Man is located in the middle of the Irish Sea, sort of halfway between Northern Ireland and the Lake District. It's home of the TT motorbike racing, 37 miles of road racing around the island. It was home to the late Sir Norman Wisdom and a temporary home to Jeremy Clarkson. And it's also believed to be the inspiration for the Reverend Audrey for the Thomas the Tank Engine and the Isle of Sodor. My kids are of that age where they grew up. Well, I am of that age where I grew up with Thomas the Tank Engine. But one of the ancient names for the Isle of Man is Sodor. The Anglican bishop here is the Bishop of Sodor and Man. And I'll leave you to make any connection you want there between the world of Thomas the Tank Engine and the Isle of Man. Anyway, moving on to the main points for this evening. We're going to go through a bit of an introduction into the different track types we've got here, some innovations and system integration work that we've done, and also cover a bit on the overhead lines. So, the Isle of Man. It's, say, north to south, it's 33 miles, east to west, it's 13 miles. It's got a population of just over 80,000. That rises significantly during TT. It's a Crown dependency, which means we're not part of the UK. We've never been part of Europe. The Queen is still head of state. She has a Lieutenant Governor here on the island, and we have our own independent parliament, known locally as the Tynwald. Hence, in this context, we are quite independent from the UK. So our friends at the ORR, the HMRI, the RAIB, they don't have any jurisdiction here. So we're very much a self-contained operation here. On the island, we have one mountain that's above the 2,000 feet limit for a mountain. Snafel Mountain is 2,036 feet, and you'll hear quite a bit about that later on as one of our railways actually runs to the top of Snafel. Looking at the railways individually then, the steam railway runs from Douglas, which is the main town on the east coast, along the southern coast down to Port Erin. It's a 3-foot gauge or 914 millimetre gauge line, operates very much as a single line with 5 passing loops. Each of the sections is controlled by a single line token. The railway is fenced, level crossings have barriers and lights, so it's very much a railway as you would think of it. It operates with the original rolling stock and locomotives. When the railway opened in the 1890s, it was a privately developed railway. In the 1970s, the railways here became nationalised, and unlike a lot of heritage and preserved railways, we're not recreating anything. We're just the railways that never got modernised. So the locos and carriages and other stock, as you see, and trams have always run. They are the original ones. They've just always run. They've never been modernised. To give you that a context, the newest loco on the newest steam loco on the steam railway and carriages were built in 1926. So actually, if we were the Isle of Wight, we'd be happy with some modern stock like the 1938 tube stock. Moving then to our second railway, the Manx Electric Railway. This runs up the east coast of the island from Douglas up to Ramsey, in the north, and about halfway along is a town called Laxy. Now, those are the three main stations on the route. It's a twin track railway, again 3-foot gauge, 914 mil, just under 18 miles long. But this one operates as a tramway, so the trams are driven on line of sight. So we don't have signalling, we don't have block sections or anything like that. It's driven very much as a tramway. We've only got one overline bridge and two major underbridges. So as you'd expect, there's an awful lot of crossings, farm crossings, road crossings, pedestrian crossings. As an electric railway, it's powered by 550 volt DC overhead line, and again operates with the original trams and trailers. Tram 1, as you can see in the top right-hand corner, the trams you can see there are tram numbers 1 and 2. They are the original trams 1 and 2 from the 1893 opening. Tram 1 actually has the distinction, it used to feature in the Guinness Book of Records as the oldest tram still operating on its original infrastructure. It runs very regularly, it's not a museum piece. Like all of the trams, they operate quite a fair mileage each day, and it's quite a good distinction. To give you an idea of what things look like, how they work, this is Ramsey Station. The tram and trailer have arrived from Douglas and are now performing a turnaround. The trams have to always be at the front, so to go back the other way, you can't drive from the other end of. You can't drive from the trailer. You have to move to the tram in front. So we have a shunting operation, and as you'll see here, we have gravity shunting, where the trailer's been pushed onto the other line up the hill. It's now coming down into position by gravity, while the tram then moves around and will shunt to be in front of it. It's one of the few places where you regularly see gravity shunting taking place, but it gives you an idea of our trams and trailers. Trailer 46 years, what we call a toast rack trailer. So it's open-sided, bench, wooden seating, and the back of the seats actually flip over, so you can always face the direction of travel. Tram number 7 there is one of our tunnel cars, as they're known, an enclosed tram. Some of the trams are open, toast rack design, some of the trailers are closed, so you have that combination of open and closed vehicles. If you're brave enough, particularly in the summer, you're welcome to have a ride in the open trailers, but I wouldn't recommend it on a wet day. So moving on to our third railway, the Snafel Mountain Railway. Snafel, again, it's a double track tramway. This time it's a 3'6" gauge or 1067mm gauge, partly because it accommodates a central fell rail, an additional rail in the middle. This is used for braking purposes, to give additional braking capability. The ruling gradient of the Snafel Mountain Railway is a 1 in 12 gradient, which is incredibly steep, pretty much at the limit of what you can work with an adhesion type railway. After that, steeper than that, you're into a rack and pinion type system. And it runs from Laxy up to the summit of Snafel. It crosses the TT course on the mountain road at a place called the Bungalow. And for those of you who enjoy watching the TT on television, you'll often see the Bungalow feature as a place where the helicopters are trying to keep up with the motorbikes. and you'll see the bikes going over the over the tracks at absolutely phenomenal speed. The line then continues from the bungalow up to the summit and actually spirals round all the way around the mountain, and you virtually do a 360-degree turn by the time you get to the summit. As I say, the track features the fell rail, and you can see it there on the on both tracks there. It's a double-headed bullhead rail laid on its side. It's raised up above the running rail level. The trams then are fitted with, on the leading end of both bogies, are fitted with a class brake that can grip the fell rail for additional great braking capacity, and the inner ends of the bogies have guide wheels as well, flanged with a flange on the bottom to help grip the wheel and ensure that the bogie stays well attached to the fell rail. The fourth railway then, these are 1 horsepower trams, literally. The Douglas Bay horse tram runs across the promenade in Douglas. Again, it's 3-foot gauge, 914 mil. It's operated currently by a fleet of 13 trams and over 20 horses. So the horses typically do 2 return journeys each day, and then that's it. They rested, and one of their colleagues takes over for the next 2 trips. What I told most of this evening's talk is going to look at the steam railway, the MER and Snafel. The Douglas Bay Horse Tram, the promenade is going through a major rebuilding project at the moment, and that would be a subject for a completely different talk in many years to come. So you won't see much about the horse tram, but you will see a lot about the other 3 railways. I'm going to pick up the story back really in 2012 when I joined Isle of Man Railways. Prior to that, the track and well, because the railways are isolated in this little island in the middle of the sea, not part of the UK, they've suffered from quite a period of underinvestment. Any investment there had been very much in terms of reactive renewals, and in some cases the infrastructure had fallen into quite a poor state. So to give you an idea, the steam railway, you can see here, this is the steam railway, just across the 3 railways, there's 60 track miles, so it's a fair length of track to maintain and look after. The track was typically 20 to 40 foot, fish plate jointed, predominantly spiked into timber sleepers. Some sections had pressed steel base plates, but predominantly it's dog spiked into the sleepers. That's part of the steam railway. This was part of the MER, and it shows the different extremes of the conditions we were finding. So, as you can tell from that, significant amount of renewals were required. So, in starting to look at what was the infrastructure made of, across the 3 railways, we had 8 different rail sections. So we decided, in terms of renewals, to standardise. The steam railway we standardised on BS80A rail, or EN39E1 to give it its modern name, and then S30 rail on the MER and Snafel. We've later added 2 different grooved rail sections as well, but predominantly we standardised on BS80 because of the higher axle load on the steam railway, and S30 then on the 2 electric railways. To give you an idea of what those rails look like, there you can see it compared to the 113A rail. S30 is quite a lot shallower. BS80 is sort of halfway between the 2. When I've come to do talks in the past, I've actually brought sections of rail with me, but I've learned the hard way that trying to get sections like this through airport security is quite a challenge. So I've stopped doing that now and just use the photos instead. So, having standardised on our rail type, we then went on to look at sleepers. We were considered, well, we knew we couldn't use softwood sleepers. That wasn't a sustainable option. So we considered composite sleepers or plastic sleepers, steel sleepers and concrete sleepers. The composite plastic sleepers were very much still in their infancy at that time, so we didn't go down that route. We thought about steel sleepers, but two issues there were at the time. The steel price was fluctuating to quite an extreme extent, so we had no reliable cost certainty on the cost of them. But also we knew that maintaining steel sleepers, you need a mechanized tamping capability, which we didn't really have available to us at that time. So we instead looked at concrete sleepers and worked with a German company, Leonard Moll, to see if we could devise our own concrete sleepers, 914 mil gauge sleepers. They had a 1 meter gauge tramway sleeper on the shelf, and were quite happy to work with us on developing this for quite low production numbers to see what we could come up with. So originally, the concept I had was to take an S30 rail or BS80 rail, see if we could produce one sleeper that would work with both. Having seen the success of the G44 sleepers in UK mainline, which are capable of taking the 113A and the SEN60 rail, we wondered whether we could do the same. So we looked at that with a Pandrel clip, something like an E1609, a smaller clip than you used to in the UK mainline. But that proved cost prohibitive, particularly because of the tooling required for the different size insulators and the small numbers. So instead, Leonard Moll suggested using a Gantt rail clip, which is like a crane rail clip with some adjustment. Now, they produced a prototype for me, which was a half sleeper. You can see that there on my office windowsill. And you see their section of rail with the Gantt rail clip. The Gantt rail clip had the advantage of quite a lot of adjustment, particularly for the smaller S30 rail, and that allowed us to use to be able to provide gauge widening as well with the S30 rail, which was one of the other things that we were looking for. We had a trial batch made. We have had quite a number made then successfully over the years. But part of what we worked with Leonard Moll to do was to make sure that we owned the final design, because we wanted to see, was it possible to have the sleepers produced here on the island. 10 years after we started the project, I'm pleased to be able to show that we have a pre-stressed concrete production facility here on the island, and that's the very first island-made sleeper coming off the production line a couple of months ago. So not only have we been able to introduce a very good sleeper, but something that can be produced locally as well. And there you can see plan view looking down on the Gantt rail clips. You can see that that adjustment that can accommodate the different rail sections. We initially produced two types of sleepers, one which had the S30 and the BS80. The other then was capable of taking an S30 rail with a check rail attached. So the fastings being that further apart. So with our sleepers and our rails, we were then left with the choice of how do we joint the rails? Do we go for jointed rails with sleepers, with fish plates, sorry? Do we go for continuously welded rail? We knew we didn't want to go for jointed track because of the maintenance liability that comes with it. We thought about CWR, but particularly with the S30 rail, the thought was, would such a small rail be able to take the compressive forces that you get? So in the end, we compromised and we came for long welded rail, length long welded rail with an adjustment switch at each end. You can see there one of our adjustment switches. They come in two forms, the S30 and the BS80. Being narrow gauge, you can't put, there's not room to put the straps in the middle, in the 3 foot as we call it, or 4 foot as you'd be used to. And instead they sit on the ends of the sleepers, one in the CES and one in the 7 foot. So you can tell our terminology is slightly different. We've got 3 foot and 7 foot, where you'd be used to your 4 foot and your 6 foot. You can see there as well the track bond. So this is on the MER. It's got the electrical track bonds in place as well. Having got that, we then started try and track renewals with all this newfangled permanent way. And you can see there one of our first sites. Our in-house permanent way team worked with local groundworks contractor who did all of the ballasting works, and then our in-house team started off. We tried panel relaying, we tried loose sleeper relaying, even the lifting beam there was manufactured here and tested here on the island, and we found loose sleeper relaying the most efficient, bringing in contract welders to weld the rail into long welded rail. You'll see on the right hand side the road alongside the MER, particularly at the Douglas end, quite long stretches have got and the road immediately adjacent to it. So as I say, that it operates as a line of sight tramway, so there's no fence in these sections either. And there you are, there's the finished result. This is looking back the other way on the same site. The left-hand track is the track that our in-house team relayed. The right-hand track was relayed a number of years later then by contractors. And this is the first section where both landside and seaside tracks have been relayed. And one of my favourite photos, I think, which shows some very good-looking permanent way there through the reverse curves. Track renewals have then continued over the last 8 years with quite a number of different contractors. We've had Manx Rail Projects working on it, Colas Rail, Alding Construction, who are part of the Colas group here on the island, TXM, SC UK Global Services have all been involved over the years. And again, you see another site here where the MER is located immediately next to the road. It does help because logistically, you've got access to the railway from the road, and with single carriageway working and traffic lights, it's been a great advantage in terms of access. But the disadvantage is we often get water from the road itself running onto the railway. So as part of this renewal that took place last year, there was a requirement to renew the curb line as well, to provide that delineation between railway and roadway, but also to stop the water washing onto the railway. Those of you who've received the most recent there we are, version of edition of Rail Infrastructure will see a really good article written by our permanent way manager Ed Saunders on track renewals.
Your presentation's disappeared, Jeremy.
Ah, right. Okay, I did wonder. Sorry, Andy. I made them clicked on the wrong bit. Let's have a look.
That's it. I can see your presentation mode, the presenter mode. That's it. Yeah, that's come up now. Yeah.
Presentation.
Yeah, lovely.
There we are. Right. Yeah, we're back on. Brilliant. Sorry about that. As I say, you can see if you've got the latest version of edition of Rail Infrastructure, it's well worth reading Ed's article. Gives you a bit more insight into track renewals, particularly these two sites. Here we are on the steam railway at Oak Hill Bridge. This was a winter 2015 renewal of half a mile of track, full renewal, with multiple sections of long welded rail. You can see the adjustment switch there, virtually right in the centre of the picture. Line side drainage on both sides, because in this cutting we've got a lot of water to deal with, and also the new access point with precast concrete steps and handrails to improve access to the site. Track renewal at Laxy Station presented us with yet another new challenge. It was our first foray into using grooved rail. We used this particular section 57R1 grooved rail, and anybody who's ever used grooved rail will know that it's particularly stiff in both directions, both axes. Unlike the S30 or the BS80 rail, it doesn't flex, so to try and change anything on the alignment, the rail needs to be pre-curved. We had ordered and had manufactured the rail pre-curved in the UK and shipped over. And when you're using grooved rail, you've got to be particularly careful with right and left hand, because with the grooved rail, you've got the groove and the keep on one side and the rail head on the other. You can't, if it's been curved the wrong way, or you want to try and swap something round, you can't just turn the rail round because of the asymmetric profile. So we learned at Laxy it's quite a logistical challenge if you need to adjust anything on a pre-curved rail, loading it back on a lorry, shipping it by ferry back across to the UK to have it adjusted, and then shipping back by ferry presented quite significant logistical challenges for us. when we were able to buy a significant volume of 55G2 rail, second-hand but unused, for use on the horse tram and the MER, we realised there were significant benefits and significant savings for us if we were to do the rail bending ourselves on island. So we set up a rail bending facility, visited our friends at Ironrod Erin and looked at their facility, and like all good ideas, we copied the good bits. We went for a Permaquip rail bender, but also using a side loader to be able to handle the rail. You can see the side loader with its frame and lifting clamps in the background as well. So with grooved rail, we've used it on ballasted track as well as embedded track in stations. And like all rail, we thought, how do we handle the thermal expansion? Putting an adjustment switch on for long welded rail would be particularly difficult with grooved rail. So instead, we welded the 60-foot length into pairs, 120 foots, and then needed to devise some fish plates. Being asymmetrical, you'll appreciate the fish plate on the gauge side is a different size to the fish plate on the field side, and you can see they're both fish plates. There we went for 6-hole fish plates to give us a very strong joint, in hope that the joint will be as strong as the weld and give us not give us any problems for many years to come. So where you've got grooved rail, you've got to be able to transition back to normal flat bottom rail, and particularly the S30 rail is quite a lot shallower than the grooved rail. So we thought about, should we use forged transition rails, but quite an expensive option for our type of railway. So instead, we worked with our friends at Trackwork and came up with a transition base plate. And you can see there that the two rail sections, the much shallower S30 rail supported on quite a thick base plate, and then the stirrups used to align it to ensure that the gauge face and the head of the rails align. Particular thanks to Trackwork. Through quite a number of different projects, I would phone them up and say, guys, I've got an idea. Do you fancy trying to work out something like this? And there'd be a sketch emailed over. And they came up with many ideas, many different thoughts for us. So big thank you to the team there. I've not seen an REPW drawing for anything quite like that before. So that gives you a bit of an idea of our track renewals on the MER and the steam railway. Move on to Snafel. Snafel, a very different railway. Access is an issue. There's only road access at Laxy station at the bottom, at the bungalow 2/3 of the way up, and that's about it. So logistics become a very important factor. So for Snafel, instead of using concrete sleepers, we've gone for composite sleepers, and you can see them being installed there. Composite sleepers, or plastic sleepers as I tend to refer to them, have the advantage of being lighter than concrete. They can be drilled and cut very much as a softwood, and you'll see the surface on the sides, and the underside's got the similar dimpled effect, so that it has good interaction with the ballast and gives you good lateral stability. The rail, the S30 rail there, is located on a pressed steel base plate with an E1609 pandrel clip. So it's a bit smaller than the 1809 clips that many of you are used to. And then the base plates are coach screwed onto the sleepers. You can see in this particular shot where we've been doing some ballast retention work then on the right-hand side. And like all good railways, the scrap rail has come in useful to support the ballast walls. Once the two running rails and the sleepers are in place, then at that point, then you start to fit the fell rail, and you can see it all gauged up there on its raised chairs, and then so that's then secured in place as well. As part of these works, where we've been doing major works, you can see line there, one of the old overhead line poles that has been replaced by a modern pole. Many years ago, in an attempt to stop corrosion and strengthen the overhead line poles, a number of them were filled with concrete. which makes renewal of them an extra challenge. But thankfully, our contractor who works on the mountain railway, Alden Construction, have got 2 road rail dumpers, both fitted with fell rail brakes. But they've got that lifting capacity as well with the dumper. It's got a small high-up crane, which makes retrieving some of the old poles a lot easier. Working on the mountain can be absolutely stunning. It can also be absolutely foul. Some days I could put a white screen up and you'd think that that's all you can see. This is a good day on the mountain. You can see the track renewals progressing, and there's the finished job with the renewed track on the right hand side and the ballast retention boards in place as well. But as I say, you get an absolutely stunning view on the mountain if you can go up on a good day. So that's plain line. Moving on to S&C. Now, those of you who've done the SO53 facing point inspections will be looking at that and think that's a failure. Yes, definitely. That's the view that greeted me. I'd only been there a few months and got called up to deal with a minor derailment on an engineering tram, and that was the view that greeted me. You can see there, not only is there not much of a web in the stock rail, but the switch rail, yeah, that's a failure, and you can work out how the derailment occurred. So with no choice but to plain line the switch. It forms part of a crossover immediately downhill of the bungalow. Came back to the office, so this chat with the director, at which point he said, okay, that's the right thing to do. You've now got 4 months to replace it with a new crossover. TT was only 4 months away, and like Christmas and Easter, you cannot change the date of TT. You cannot postpone it. It's one of those fixed events in the island's calendar. And this crossover becomes absolutely critical to operations during TT when the road is closed. So given 4 months from a standing start, we quickly came up with a new geometry for a standardized turnout and made sure that would work across most of the turnouts on Snafel. And again, working with our friends at Hall Rail, or track work as they became, we, within 4 months, designed, built and installed our first new crossover using what became the standard geometry, some of the details that became standard, as well as the long timbers, the hardwood timbers. We fitted a full length sole plate, metal sole plate under the first long timber with the welded gauge stops, and that extends actually right underneath the point lever as well, so that the point lever is connected both on the first and the second long timber by the metal sole plate, just to stop any movement. When on the crossover that we actually replaced, the point operating mechanism was on a block on its own, remote from the track, and had also started to move. So I was maybe paranoid, but decided to adopt some best practice from the UK and adopt sole plates underneath point machines, just to make sure everything's locked together. The geometry became standard, and in the intervening 8 years, we've renewed all 9 of the S&C units on Snafel Mountain Railway. 7 of them being renewed with this standard geometry, and the 2 that weren't with standard geometry we'll look at next. At the summit of Snafel is a rather unique set of points. There used to be one at the bottom end and one at the top. The one at the bottom end was renewed to a different form many years ago, leaving this single-bladed point at the summit. For those of you who are trying to work out how it works, the switch rail pivots at the nose of the crossing. The switch tips move full 3'6" from one side to the other. This is pretty unique. I've not seen them anywhere else. But when this one came up for renewal, we were left with 2 choices. We thought we could either renew it with a conventional set of points, but I think the engineer in us all thought actually we wanted to try and maintain part of the heritage here, and something that is, well, I think is unique. So as part of the renewal, we looked at trying to correct a few other challenges on the site. You can see there the tram is very close to the station building, so we wanted to move the track a bit further away from the building. But also the layout of the paths and the different features of the summit means that people generally actually walked through the middle of that set of points. The pathways just generally went through that greased up area. So we wanted to try and move things around a bit so that we got rid of that problem as well. So working with our design team on this one, it was GHD as our designers and our friends at Trackwork. We fabricated a new single-bladed point. You can see it there in the works. And there it is, installed with the blade at mid position there. On the right-hand side is the point lever. You'll see after this photo was taken, we improved the surfacing around the point lever as well. But the station area actually stops right at the bottom of the photograph. You can just see the edge of the surfacing there. So it allows passengers to walk through where they need to, but still see this rather special set of points. So having come up with this renewal, we then started to think, well, how do you fit a facing point lock to a set of points that has got a switch opening of 3'6"? And again, it came down to a bit of practical thinking. When we were doing the acceptance test with Trackwork at their depot, we realised that the point lever actually rotates with a crank then to produce that movement. We thought, well, actually, the point lever could do with being a bit longer. So to prove this, a piece of scaffold bar was purloined and used, and we found that that extra leverage was definitely an advantage. Having that scaffold tube in our hands, we then came up with the idea of adding some pockets to the base of the crank, and as you can see here, there are two pockets, and basically that scaffold bar fits into one pocket and holds the crank in position, either to the left side or to the right side. So it means that our operating colleagues, when they come to operate the points, take the scaffold bar out of that tube and unlock the points, put the tube onto the handle to operate it, and then put it back in the other side to lock it. Quite a simple operation, but it just means that we actually have a facing point lock there as well. Moving to the other end of Snafel, back down at Laxy, you can see here pretty much the bottom of the mountain. Laxy station's in the background. Trams leave Laxy station, come across the level crossing, and then start to climb up the 1 in 12 gradient for 5 miles. The line speed is only 12 miles an hour, but a 5 mile an hour turnout at the bottom would provide quite a restriction for them. So Snafel is unlike the other railways where it's right-hand running, so the uphill trams are on the left-hand track as we're looking, and therefore have to take the turnout route. So we devised a separate geometry suitable for 12 miles an hour. So this is the high-speed turnout on Snafel, to allow the trams to start to get just that little bit of momentum up at the bottom of the hill before starting to climb. And there you can see it looking the other way, and it gives you an idea of just how steep a 1 in 12 gradient is for a tram to climb. If you look at the points as well, something else that became a standard feature for our S&C, as well as the continuous sole plates, the stretcher bars are different to normal. And they are, you can see with the stretcher bars, they're not only adjustable to make them quite easy to set up, but they have pivots at each end. Anybody who's seen fixed stretcher bars will appreciate as the switch moves from one side to the other, if they're both set up at both ends of the stretcher bar set up at 90 degrees to the various switch rails, the stretcher bars actually flex. It's more of an issue if you have standard openings on a narrow gauge set of points. The flex becomes even more of an issue. So we devised a set of stretcher bars that have pivots at each end to get rid of that twisting effect, and then also have the turnbuckle in the middle to allow us to adjust them. And those have been rolled out now across all of the points as they've been renewed, both on Snafel and on the MER. And this set of points this is the entrance to Snafel Shed. So this is on the down line, again with right-hand running, the trams are running downhill here. This set of points always had a facing point lock, but traditionally it was a nut and bolt put in place through a hole in the stock rail and the switch rail. So we decided to see if we could improve that when the points were relayed. And thanks to our friends at Network Rail, they supplied us with a full ground frame and facing point lock kit. We set about fitting it to a 3'6" gauge set of points with S30 rail. One of the big challenges with S30 rail is how shallow it is. And actually the body of the facing point lock is taller than the rail itself. So to get around that, the sole plate on the first long timber was manufactured with extra thick base plates to allow that timber to drop down by about 30 mil to give us the clearance for the facing point lock. So there you can see our ground frame with the facing point lock. Again, the sole plates continue all the way along the long bearers, so that the drive crank is actually bolted again through that sole plate, just to make sure everything's locked together. Moving on to the MER, it's very much similar sorts of things. Standardised 1-in-7 geometry with the rotating adjustable stretcher bars. This is Laxy wash floor following Renewal there, and again over the last 8 years, the vast majority of the S&C on the running lines have now been renewed in this what we call our standard S&C. This is Ballaskeag up at the northern end of the line. This was renewed in the last couple of years, but this one by our in-house team, and this one uses the composite plastic bearers. It's the first time on the MER we've used composite bearers under S&C. And then at Port Erin on the steam railway, again, we've not done a lot of S&C renewal on the steam railway, but where we were remodelling the very end of Port Erin, we moved the S&C and took the opportunity to put that on the composite plastic bearers. And even though it's within a heritage station environment, you really wouldn't tell that those aren't wooden sleepers. So we've looked at rail, sleepers, ballast, S&C. What else do you need for a railway? Well, as I mentioned, we've not got that many bridges, but we have got multiple level crossings, farm crossings, pedestrian crossings, and road crossings. So this is one on the steam railway, the first one that we look to renew. Traditionally, when we've done level crossing renewals, it's been by casting a thick reinforced concrete slab under the road, directly fastening the rails to it, and then building up the surface with a blacktop to take it up to rail level. It makes accessing the rail very difficult. It's also very expensive because of the amount of reinforced concrete that has to go in. So we worked on this one with Rosehill Polymers, Rosehill Rail, to devise a 3-foot gauge BS80 polymer panel system. As a number of rail operators, London Underground and some of the tramways, and I think Docklands Light Railway used BS80 rail, they already had a mould that would work for BS80 rail, but not for a 3-foot version. So we worked with them and looked at how that could work with our concrete sleepers. Came up with something that worked there. This was the first level crossing we renewed. It actually formed the entrance to a children's home, so we had to put in a temporary crossing over the winter while we worked at this site. But there's the end result. Local groundworks contractor did the ballasting for us and also did some of the blacktopping, but our in-house team fitted this. It was very much a first of type, fitted it, and then our off-track joiner did a superb job with the fencing, the anti-trespass guards and all the other woodwork associated with it. So we fitted that on the steam railway, we fitted that on the MER, but one of the challenges is to get something that will work on curved track as well as straight track. So in a year or two ago, Ed and his team started discussions with Edelon Cedra to see if their precast track panel system would work. And as you can see there at just beyond Groudle Station, that's a level crossing with the S30 rail embedded into channels in the precast panels on a 23-meter radius curve. For those of you, 23-meter radius, if like me, you come from a heavy rail background, 23-meter radius curves just look crazy tight curved, tight radius. When I first arrived, I thought, well, I'll try and work out actually what this radius was, and came to try stringing it. And if you put a 20-meter cord along there, you'd probably be in the middle of the road with it. When we tried it, even with a 10-meter cord on the outer rail, the Versine was 1 meter plus, so it actually came over the 7-foot rail as well. So you soon learn that things like Hallards don't work on particularly on tight radius tramways. But as I say, the Edelon Cedra panels, the second one has now been installed further up the line in the last year or so as well. So we have a number of different systems available to us. For Snafel, again, back up at the summit, we wanted to try and help delineate the rail corridor from the sort of general pedestrian areas. So we developed these panels. They're a bit like you think of them almost a bit like a BOMAC type panel. It's actually mass concrete with fibre reinforcement added to it. Panel that sits supported on each bearer. Each bearer is actually a long timber, so it goes all the way out on both sides, but allow these to be removed if we need to access the track. They also have the benefit of an anti-slip system on them. Apologies for the quality of the photo there, but the raised dimples are actually the 3 legs of man. So these are produced on island for the island, and we not only have the 3'6" version for Snafel, but now also have 3-foot versions, which are great for pedestrian crossings on the MER. Like all good railways, road rail plant has become a feature in recent years. I say on the mountain we have our contractors have 2 road rail dumpers fitted with fell rail. We also have a number of items of 3-foot gauge of our own. The dumper on the left was originally brought over by TXM Rail when they came over, and is now part of the island's railway fleet. On the right, we've got a MEC 4 battery operated inspection cart with a small trailer, and at the bottom a Wickham trolley. We've actually got 2 Wickham trolleys. This one's been rebuilt quite recently with its own trailer, and the other one is very much more the original mechanics. For those of you who are into vintage cars, the other one has got a Ford side valve engine as seen in a Ford Anglia, so it gives you an idea of its vintage. But I say we have some plant. We also have to make sure that we're not only looking at renewals. Part of our maintenance, track inspection is very important. It's one of those keys that tells you, make sure you know what's going on. With track inspection, back in 2011, we introduced standard patrolling length, so agreed where each patrol would start and stop with clear diagrams for each one, so that everybody started and finished in the same place. We also then had paper record put into an Excel spreadsheet as a basic database. Everybody who's involved with any sort of railway inspection paper-based will know that rain, wind and all the rest of it can get the better of you at times. So adopting some new technology, we worked with our government IT colleagues to produce an iPad tablet app that allowed us to record each inspection and also any defects that were found. Using drop-down menus, it meant a standardized approach helped with the searching in the database. And then that's been further developed so that not only have we got defect inspections, we've got defect rectification paperwork that shows how each defect is closed out again. Something developed quite a simple database in-house. The tablet records the location, not only if it's on the MER Snafel by pole numbers or trainage markers on the steam railway, but it can also log GPS location, photographs, and if it's a particularly bad fault that needs urgent rectification, it allows the inspector to email the details through as well, so that the supervisor can see the photos straight away. Anybody from a heritage railway background, this isn't rocket science. It's quite an easy thing for any railway to develop themselves. So that's been a permanent way, very much a permanent way. What other sort of integration things have we had to deal with? Well, we've had to look at wheel rail interface. We've got a number of different rail sections. We've got a number of different types of vehicles. So Manchester Metropolitan University and then Huddersfield did a number of studies for us. And what we found was that even though we've got 3-foot gauge, 2 3-foot gauge, or 3-foot gauge railways, it wasn't possible to have one wheel profile that would work on all of them. Tramways, the horse tram and the MER, tramways traditionally have very narrow flanges, whereas the steam railway has a railway type, much thicker flange. So we ended up having to accept the fact that we couldn't have a common wheel profile for them all. In terms of gauging, again, one of the first things I was given when I got there, one of the few pieces of paper I was given was a diagram of the structure gauge. Great, I thought this is great. We've got a structure gauge. So we set about trying to survey the bridges to make sure that they were clear of the structure gauge. What we found as a result of the IRIS project, when a pump sewer was put underneath the railway, the track, when it was handed back quite a bit higher, until we'd lost some of that clearance for quite a few of the bridges. We devised quite a simple way of surveying the bridges using a laser disto which had an inclinometer built into it and automatically gave us the bridge profile as a set of XY coordinates. We're able to put that into an Excel spreadsheet, put the vehicle profiles in as well. You can see the outline of the steam engine, the carriages, the diesel loco with its shunter with its wing mirrors. The spreadsheet then was able to, we devised it so that it could apply cant. It could also apply end throw and centre throw. So you've got that static but realistic cross section. And as I say, what we found is some of the bridges were quite a way inside the structure gauge. Thankfully, we picked this up before our rolling stock colleagues went ahead with their plans to fit replica oil lamps to the roofs of the carriages. When we talked about it, they said, well, it's okay, we've checked the structure gauge and everything's okay. Had they actually gone ahead with it, I think we would have been minus a few replica oil lamps had it gone under this particular bridge. So as a result of all of this surveying, we've actually reset the structure gauge to be far more realistic, and now have a way of assessing our structural clearances. On the MER and Snafel, the trams, as you've seen, are very much a rectangular box, so it's quite simple. And with the absence of overbridges, the clearance factor for them is the overhead line poles that are located in the middle of the 7-foot. So we started off with just a rectangular box and the poles. And what we did was to measure the inclination of the poles. Were they vertical or were they slightly off vertical, to allow things to be assessed? As time's gone on, we've changed things and improved things. You can see this is an MER cross section. The effect of a 24-meter radius curve, you can see the effect of end throw and centre throw quite marked on that diagram. But with some refinement and laser scanning of the trams, we've been able to look and see very much the key area is the step, the corner step. In terms of clearance to the rock face, your groudle, but also in terms of clearances to the curbs as part of the renewal work. Moving on then finally to talk about overhead line. On the MER, power is collected by roof-mounted trolley poles. The trolley pole is mounted in the centre of the tram, always running behind the tram, so it's always trailing. And on the end of the pole is a small wheel, about 8-10 centimetres diameter wheel. It's a grooved wheel that's pushed up onto the underside of the wire and allows the power to be collected. Traditionally, the overhead line wire has been a round wire, and that's fitted into the groove. If you look at this diagram, you can see there the copper wire fitting into the top of the wheel. That's great when you're going along, but if as the tram moves and the wire and the tram are no longer parallel, it actually has the effect of twisting that wheel and narrowing the groove as the wire sees it, pushing the wheel and the wire apart. In the early 1900s, a simple modification was made on most tramways to actually allow that wheel to swivel in the horizontal direction to always stay parallel to the wire. Ours have never been modified that way, so we've got that original trolley wheel and trolley pole arrangement, which can be a bit of a challenge. Also, as our friends in South Wales who've now got overhead line wire have found out, wires don't stay up there on their own. They actually need to be supported. So if you take a trolley wheel there and the wire then is supported, if it's a round wire, it has to be clamped in place. And what we found was the wheel actually clashed with the clamp, and you would not only get an impact of the wheel hitting the outside of the clamp, so that put a shock load into the clamp, and occasionally the clamp's left go and with a dewirement, but also the wheel would be pushed down underneath the clamp, and as it came back up the other side, making contact with the wire again, provided it didn't actually come off the wire, you'd end up with an arcing taking place around each of the clamps. That led to a lot of heat and damage to the wire and softening of the wire. So we had quite a number of wire breaks, particularly around the clamps. They didn't tend to break in the middle between supports. It was always at the clamp. So adopting new technology, and don't ask me which decade of the early 1900s that this came in, but we had instead adopted grooved wire. A grooved wire, like a figure of 8, and where it's clamped in place, the clamp can fit higher up the wire and end up being clear of the trolley wheel as it goes through. So you don't get the impact, you don't get the arcing, which has led to a lot of benefits for us. It's a bigger cross section being a figure of 8 shape, so we get less voltage loss as well. Our overhead wire team have been working, and again, over the last 8 to 10 years, they've renewed 45 kilometres of overhead line wire out of the total of 55 kilometres on the route. So they're nearly there with a full renewal. And now, instead of wire breaks being measured in weeks, they're now, well, if we have 1 or 2 a year, that's now a significant event. So there's been a great improvement there. We've also renewed 4 out of the 5 substations with modern control gear as well. So the overhead lines very much had that improvement as well. Just to give you a quick view of, this is the trolley pole on the trolley wheel and the trolley pole. Hopefully this will just give you an idea of what that little wheel goes through on its journey. You can see the tram and the wire start to get out of alignment with each other, and then as it comes to each support, you'll see the change in direction that it has to take. This was filmed on this particular curve. We're only running at about 10 miles an hour, but you can imagine what the life of this wheel is like as it dances around with the overhead line wire. So moving on then to Snafel. Snafel trams were originally built again with a trolley pole, but that was found to be particularly unreliable given the high winds that we get at the top of the mountain. So fairly early in their life, the trolley poles were removed and bow collectors fitted. these bow collectors are of a fixed height, so they're not like a modern pantograph that's spring-loaded upwards. They're a fixed height. But if you look along the length of the wire, you'll see that the wire actually sags between supports. The reason why there's two bow collectors is as the tram, this one as we're looking at, travels uphill, the front bow collector, the wire will lift off the bow collector and be clear of the bow collector, so it can actually pass clean under that support so there's no impact there. But the front bow collector has to make contact with the wire before the back one leaves, so that you've always got power coming through. This system works relatively well. There are a few drawbacks. In hot weather, when the wire expands, you end up with it sagging more, and that puts quite a vertical load on the wooden body trams, because you've got this wire. You can't tension the wire because it's got to have that sag in it. So you end up with quite a weight pushing down on the roof of the tram. And in cold weather, when everything contracts, the wire actually lifts up and can sometimes end up with both bow collectors being clear of the wire, which at that point you've got a fundamental problem. Together with the weather and being very much a sort of tourist railway, it's one of the reasons why we don't operate during the winter season. So anyway, that gives you a good introduction to some of the infrastructure, particularly the track here on the Isle of Man. With all presentations, with all good railway work, it's a team effort. I'd like to thank, but I'm not going to name all of the colleagues involved because there are so many: suppliers, designers, contractors, basically everybody who's been involved with this over the last 10 years. It's a real team effort. But thank you to you all for your input. So there we are. I think that that sort of brings that presentation to an end.
All right. Thank you very much, Jeremy. That was really fascinating, and it was good to see. It's nice to know that they haven't actually instituted a modification to the trolley pole that came in at the turn of the last century. Right, have we got any questions? We haven't got any questions yet. Does anybody want to ask a question? All right, well, I'll ask a question then. This sort of drive to standardise and make your own equipment, how much do you reckon you've saved by actually making this concrete sleepers on the island?
I'm not sure. What I do know is that say the concrete sleepers either come from Germany or even further into Eastern Europe. So the transport is quite a significant factor. So by being able to eliminate the transport costs, I couldn't put a figure on it, but it's quite a significant chunk of the cost. I think in terms of standardizing things like the S&C, because all of it's relatively new, we've not actually had to deal with maintenance replacements yet. But I hope that in the generations to come, they'll be able to reap that benefit of standard S&C components as well.
Yeah, so just a few crossings and a few types of switches. Right.
Yeah, very much so.
Right. Let's see.
I see there was one question, Andy, about the length of the long welded rail.
Yeah, I'll just coming out now. Yeah. So yeah, Paul says, how long are the long welded rail sites? Yeah.
Each of the length long welded rail is 150 meters. That gives us, we did an exercise where we measured rail temperatures here on the island and compared them to historic air temperatures. We actually found that the range of temperatures that we had to cope with was smaller than the UK. The island being predominantly coastal, we didn't get the very high rail temperatures or the very low rail temperatures. So that allowed us to have that reduced range of temperatures, and that then determined how far, given the expansion available on each adjustment switch. So most of the site, all of the sites, it's every 150 meters, but we have multiple sections abutting each other. so that as with long welded rail, basically half of each length breathes in each direction, and the adjustment switch has to be able to take the movement of both sides, and hence where we came up with the 150 meters.
Yeah, it is a practice that was used by various. London Underground used it for many years. A situation like that, and people like the Great Central Railway also had tight joint fish plates with no gap, and then a scarf joint every, I don't know, 5 lengths or something to allow the expansion, but give you a much smoother ride. Right, Stephen Long says, thanks, Jeremy, really interesting. For your bespoke component solutions, e.g. the transition joints, what do you hold for spares?
I think probably only 1 or 2. They are very much made to order. None of this is more than a few years old. The Renewal in Laxy Station, which was the first use of grooved rail, was, from memory, about 7 years ago. So we've not particularly had a problem with things coming to the end of their life yet. We have two different rail sections for grooved rail, and it's only used on the MER, so it only abuts S30 rail. So we wouldn't need that many, but they are right and left hand specific to actually work with the grooved rail.
Yes, the trouble with grooved rail, it's all handed, isn't it? Yeah.
Yes.
Right. Matt Field says, what do you use for tamping?
We predominantly use the Pandrel, the Robel hand tampers. They've proved most effective. We do have a Harsco tamping machine, but it's a jack-a-packer, so there's no lining facility on it. There's no surveying facility or anything like that you'd get on a more modern machine. So what we found is that, and our contractor's the same, is that it's more efficient to actually do it by hand, and that the Robel machines seem to work very well for us.
Good. Okay. Yeah. So you haven't thought of buying a meter gauge one and converting it or something? So
we did some work with Shtelski, and the guys, they did a lot of good work with us to look at. They have got a I think it's a 900 mil or meter gauge machine over in Europe. At the time, one of the big issues for us was actually how to run the ballast out. We didn't have any 3-foot gauge road rail plant at the time,
right.
and even a single dumper is going to take a lot of runs to run the ballast out. So basically we couldn't take that one any further. As the railways operate, we operate generally from Easter through to early November. So we have the winter as a possession. That may sound like a real luxury, and I'm sure friends at Network Rail would love to have a 4-month track possession every year to do their work. But some of those logistics hamper us just as well as that's the flip side to having the good possession time.
Yeah. It's a long wait for the next one. Yeah.
Yes. Yeah.
Right. Paul Ebbert says, what is the typical standard MER S&C geometry?
The S&C geometry on the MER is a 1 in 7 crossing. I can't remember the toe to nose length. The Snafel, it's a 1 in 5 3/4, and I think on the steam railway it's about 1 in 8.5. So again, each one has got it, because the gauge is different. Particularly, each one's got its own design.
Yeah, I guess on the steam railway you've got to accommodate for the longer wheelbase on the locos and things as well, haven't you? So,
yeah.
Right.
Yeah.
Andrew Wilson says, Jeremy, fascinating. How many men are in the team, and are they multi-purpose maintenance and renewal men?
Right. Our in-house track renewals team, track permanent way team, is about 12 to 15, plus assistant permanent way manager and a permanent way manager. They enjoy doing renewals as much as they enjoy doing maintenance. The challenge always comes is that if you use your maintenance staff to do renewals, there's nobody left to do the maintenance. So what we found is that it's easier to contract out the renewals work and let our own staff very much concentrate on the maintenance. But as I say, you've seen some of the work that our guys have, the renewals work that our guys have done, and particularly in the early years, they did some of the first of type work where we needed to prove whether this thing was going to be feasible or not, and then help the contractors then to have an idea how to take things forward.
Oh, good. Right, Manny Jagannathan says, thank you for an informative presentation. Will you be able to share how the hazards related to human interaction are mitigated, particularly where the track are so close to the road and level crossings on a very tight curve?
I think this is one of those real challenges that anybody operating Victorian infrastructure has. You certainly, if you started today, you wouldn't design it. The clearances that our forefathers blessed us with, to be positive, are challenging. Therefore, it's essentially grandfather rights is a big way of how we have to approach it. But on the open trams, the tow track trailers, all the passengers are warned by the staff before they start not to lean out the window or to put your arm out the side. The conductor sits at the back of the tram and is always looking back into the trailer and very much keeps an eye out for anybody who thinks I'll just point my camera out as I'm going past, and will warn passengers. I think having ridden in them many times with children, with my own children, a sense of self-preservation also comes into play, and also our line speed is very low. Typically on the sharp curves, you're lucky if you're doing more than walking pace. Line speed is 20 miles an hour or less, so it's very different to a mainline arrangement.
Do you get problems with motor vehicle incursions onto the track?
Yes, but particularly motor cars. Cars do come onto the track. We have a good working relationship with the local constabulary. But also people understand the risk and are very good at informing us if there's a problem. With driving on line of sight, you've got to be able to see any hazard and stop within that distance, so that the motorman has to manage his speed accordingly. So where sighting is poor, they slow down. So we have quite a number of open level crossings, and it tends to be the locals who unfortunately are the drivers involved in collisions. A car versus a tram, the car never wins. Even though they're wooden body trams, the tram always wins.
Yeah, well, they have a nice hefty coupling on the front and things like that, don't they?
Yes.
Yeah, okay, right. There's no more questions now, so I'd like to call upon Matt Field to propose a vote of thanks. Are you there, Matt?
I'm here, yeah. Can you hear me?
Yes, I can. Thank you, Matt.
Evening, everyone. Jeremy, that was amazing, to be honest. I'd say I'm relatively new to the P-Way game, but seeing some of the innovations and the constraints you've overcome is definitely inspiring for me. I suppose one last question I'd have is: have we got any plans to improve the horsepower of those first trains?
It is actually, but we have one on our horse-drawn trams. We actually have one tram, which it's known as the double-decker tram because it's double-decker, and that fully loaded is occasionally hauled by two horses together side by side. So there you are. That's how you double your horsepower in one easy step.
No, that's great. I mean, thanks very much for your time, Jeremy, taking your time out to give this presentation. You have to forgive me; it's my first time on the online scene of this, but Do we all give thanks in the chat, or can we put our mics on, give a little round of applause to Jeremy? Or
I think we'll put our microphones on and we will give a round of applause in the usual way. Okay.
that'd be great.
Thank you very much, Matt, and